Donc, bonsoir à tous. Donc, je suis très heureux de vous avoir ce soir, c'est pour notre série de webinaires. Donc, ce webinaire, il est à propos du changement climatique et de ses impacts à Maurice. Donc, le webinaire, il est financé par le CEPF et par Ebony. Donc, le but est de sensibiliser sur les différents problèmes environnementaux de nos jours et comment mieux protéger notre faune et notre flore. Et donc, Ebony, nous sommes à Chamarel et on travaille sur la conservation et principalement sur la restauration des forêts. Et comme j'aime bien le dire, c'est plus écosystème restoration qu'on fait. Donc, et bien sûr, Ebony est ouvert au public et les gens peuvent venir visiter pour le travail qu'on fait. Donc, pourquoi on a décidé de faire ce webinaire? C'est que on a réalisé que beaucoup de personnes ne savent pas ce que c'est le changement climatique et les impacts qu'il a sur la vie de tous les jours et dans la nature, et encore moins à Maurice. Donc, on a pensé que ce serait intéressant d'avoir ce webinaire. Et ce webinaire, il s'inscrit dans une série de webinaires. Le premier sera sur les changements, sur les impacts du changement climatique. Et les prochains webinaires seront sur comment atténuer les impacts négatifs du changement climatique. Donc, ce sera une série. Donc, celui-là est le premier. Et ce soir, on a un panel d'experts. Et moi, ça me fait grand plaisir d'être parmi ces experts-là parce que beaucoup de ces personnes qu'on a ce soir, ils ont joué un rôle prépondérant dans ma carrière à moi. Donc, moi, ça me fait super plaisir d'être là parmi eux ce soir. Donc, dans le panel, on a Vincent Florence qui va faire l'introduction et nous parler de ce que c'est le changement climatique. On aura Vikash Tatayad qui nous parlera de l'impact du changement climatique sur la faune à Maurice. Vincent Florence sur l'impact du changement climatique sur la flore. Vasen Kopemoutou sur l'impact sur les coastal areas et les océans. Et Yannou Kumsing, l'impact sur l'économie et les business. Donc, on prendra les questions, on aura un temps de questions vers la fin. Et bien sûr, si on a quelques minutes, on prendra quelques questions. Donc, sans plus attendre, je vais passer la parole à Vincent Florence.
Alors, oups, vous voyez là? Bonjour à tous, bonsoir plutôt. So I've made my talk in English, is that fine?
Of course.
I'll share screen with you. All right. Here we go. Can you see that? Okay. Are you able to see?
Oui, c'est bon.
Okay, excellent. Merci. Okay, so welcome everybody, and I'm really pleased to be here, and thank you very much to Nicola and Christine, Christelle, and all the team for inviting me here. I'm really delighted to be here. So I use your cover photo for my cover, the first page. So, and I quickly present myself. I'm from the University of Mauritius. I lead a small pool of research called the Tibet Tropical Island Biodiversity Ecology and Conservation. So I have a little outline for you. First, we begin to talk a bit very briefly about the introduction on climate versus weather. A little word on time scale. You will see the talk is given in a bit of detail, but I will skip through it quite quickly so you can look at it if you want. The recording can be made available on the web if you want to go into more details later on. But anyway, the second point I'll be talking about is natural drivers of climate change, because there's a lot of confusion. Many people say, no, it's natural, what's happening, etc. There's no, climate change caused by humans, a hoax, and all this a hoax from China. So we will need to clarify a little bit these natural drivers, what they are, and then what are human-caused climate change, and then some examples of effects, connection and feedbacks, etc. So basically, the first thing which is important to know is the difference between weather and climate. Weather basically is the actual state of the atmosphere at a given moment, at a given place, over a few hours or perhaps days. So for example, if I say it rained 12 millimeters in Cupic and 32 millimeters in Pori today, well, I'm talking about the weather. So, but if I'm talking about climate, then I'll be talking about an average of that kind of rainfall, for example. I'll be talking about the mean rainfall, the variability, etc. And I will have, for example, the text in italics here, the mean annual rainfall is, say, 1,000 millimeters in Cupic, 1,000 millimeters in Pori. I'm now talking about climate. So the climate, basically, we can then say Cupic has a wetter climate than Pori. So you get the point. So weather and climate are very distinct, and it's very important to get that right, because you might think it's very simple, but it's not so simple for some people. For example, here we have a senator in the US Congress who is using a cold day to try to debunk the existence of climate change. I mean, on 26 February 2015, it was indeed cold, and Mr. Jim Inhofe brandished that ice ball to say that climate change is a hoax. But in reality, he's mixing up climate and weather. So because 2015 indeed was the hottest year on record. So he went into history now, Mr. Senator Inhofe. So it's very easy to make this kind of misconception, and you hear it a lot. And unfortunately, people like Inhofe, they are actually legiferating. They're making laws. They are pushing or not pushing for climate change mitigation, etc. So it's very important to get it right. So now the other thing which is important about climate change is we need to know that there are different scales. There's variation, for example, in terms of decade to decade. You can see variation in that case temperature. You can see the variation here, but it's all squashed into that small area here. When you look at it on the century scale, you see that the years here are much bigger. And then that's all squashed into this very small line here, which is per millennium. So you have different patterns happening at different scales. Here, for example, you have the interglacial patterns, but here you don't see that interglacial patterns. You have other kind of variation, and here you have even shorter times of variation. So there are different factors influencing climate as we know it. So, and climate change has been happening all the time for millions of years, and there are many natural causes. Plate tectonic is one of them. When you have land masses next to the poles, for example, you tend to have more ice and accreting. And when you have ice, you have more reflection. You have less heat, accumulating in the earth. So it influences the temperature of the atmosphere. The more ice you have, the more reflection you have. The darker surfaces absorb heat, etc. So things like that are important. And of course, these changing location of land masses on Earth influence the wind and current patterns, and all this influence the climate. But the other major natural cause of climate change is volcanoes, of course. A lot of gases in the atmosphere. It can create a kind of blanket that actually heats up prevent or reduce the release of energy from the sun, reflecting back out to space, for example. So another example of natural cause is the sun radiation itself, the sunspot, and all these things. You have cycles on the sun of activity. For example, here it's interesting. Many people say to you, "Oh, it's getting warmer just because of what is happening on the sun. So it's nothing to do with carbon dioxide, etc." So there is some kind of cycle. You can see here in yellow is the solar irradiance, and red is the temperature. So there is some kind of correspondence at the beginning, but now what we can see in more 50 years or so, you see that the decoupling. So as the solar radiation is decreasing, the temperature is increasing. So basically, we cannot say that it's sun driving the climate change, the heating that we have on the planet today. So, but that's one important aspect of the natural cause, but also over that, we have human impact. We will talk about that later. There's other examples of natural cause caused by, for example, orbital changes. Just look at only one of them. The Earth is not always the same distance from the sun, so sometimes it's more elliptical, so it's further away. So that creates some kind of differences in temperature, obviously, because of the proximity. But that's over a very large scale, in thousands and thousands of years, to create the climate, their interglacial and glacial periods. Greenhouse effect, we have heard about it. Carbon dioxide have always been there, even well before humans existed. Methane as well, nitrous oxide, all these are greenhouse gases. Greenhouse gases are like a blanket that you put on top of the planet. If you put the blanket, you get warmer. It's as simple as that, anyway. So now, greenhouse gases, the main ones, don't look at the detail of this slide, just the main one, water vapor, carbon dioxide. They are important ones that actually will, the more there is in the atmosphere, the warmer it gets. So now, when it comes to human impacts, you have carbon dioxide, which is released by deforestation, by land use change, burning of fossil fuels. All right, so things like that. We have increased it by 47% since the Industrial Revolution began, which is a very large margin. And methane, which is another very important greenhouse gas, is caused by decomposition in wet landfills, agriculture, the cattle, etc., cultivation of rice, domestic livestock. So what we have carbon dioxide is increasing, and you can see here the extent in the past, the natural extent, and now it has really shot up very much because of Industrial Revolution. And there's a very clear increase of all the greenhouse gases, as you can see here. Carbon dioxide, methane, nitrous oxide, we talk about. And it is tightly correlated with temperature. The more carbon dioxide you have in the atmosphere, the more greenhouse gases, the hotter it gets. So some of the effects, therefore, is heating. We are having a situation of heating. You can look at that these in details later on. We have droughts and heat waves are happening more and more often. We have increased, for example, since the late 19th century by 1.2 degrees about. We're hotter now. So that creates more droughts, more heat waves, more wildfires, more failed crops, more water scarcity, and things like that. And now it's also influencing the ocean. Ocean is getting warmer, and what it means more evaporation, therefore more clouds coming in. You can have more floods, more cyclones, more extreme precipitation. So you can see there's many different ramifying influences. Decreasing ice cover in Arctic, for example, is also happening. So less ice, therefore the Earth absorbs heat more. So there's a kind of positive feedback situation. It makes the ice melt faster, and then you have more heat accumulation because the sea is a darker surface, so it absorbs heat better than a white, snowy surface. You have decreasing glacier cover. For example, in 1914, this glacier here is now a lake, and that is worse than even really bad because it creates sea level rise, because all this water goes to the sea eventually, because of glacier melt. But also water expansion. That's another influence that makes the seawater sea level rise. You have greater storms intensity because of that, more flooding, saltwater intrusion in aquifers. You have to abandon fields and lowland to move further inland because you can't cultivate your ground anymore. And now the prediction there, business as usual is terrible. It's historical, it's black here. You can see it's getting bad, but business as usual is getting us into very uncharted territory, really, really bad. All these things I've been telling you, it's getting much worse if you don't do anything. So we really have to do something. So we are also having change in rainfall patterns. Not everywhere is getting drier. Some places are getting more rainy, others less. We have more extreme weather. You have more heat, more drought, more rain, flooding, etc. So you can see the extent of it. It's about finished. Then cyclones get stronger. That's more interesting for Mauritius because we are in a cyclone belt. And the other thing that just to finish up on that, there are feedback loops. For example, when you have more melting, a higher temperature because of all this heating, you have permafrost, for example, in a very high latitude, they melt and they release methane. Methane itself is another potent greenhouse gas that causes more warming. Therefore, you can see that there are situations where the warming causes factors that accelerates the warming. So it's kind of positive feedback situation. So there are problems of that kind. So, and I think I will be stopping here because I just by a few seconds shot over 10 minutes. Thank you very much. If you have a question, we'll take it at the end. Thank you.
Thank you very much, Vincent. So, like you said, we'll take the question at the end. So now we'll pass the floor to Vikash, who's going to talk to us about the impact of climate change on the fauna.
Give me a second, please. I'm just getting set up. I'll be with you in literally 30 seconds. Thank you very much, Vincent, for that presentation and a nice introduction to what I'm going to be saying soon. My slide now?
Yes, it's good. Okay, we might have a problem with Vikash. Let's see if we can get him back. So maybe while we're waiting for Vikash to come back, Vincent, I don't know if you would like to talk about the impact on the flora, if you don't mind.
You want me to set up you? Okay, I can set it up. I told before Vikash, then you mean?
Yeah, if you don't mind, then I'll try to get back Vikash.
Okay, no, I don't mind. Just let me save the file. Yeah, okay, and then I'll share it. Just a minute.
Thank you very much, Vincent.
You know, no worries. I just put my timer again. Okay, 10 minutes. Okay, it's me again. Okay, I didn't change name. Here we are. So I think you can see my slide now. Is that okay?
Yes, we can.
Okay, Christian told me the connection was a bit poor. So, you know, give me a shout if there's a problem, if you need, I need to talk slower or whatever. So, right, so we're going to talk about climate change impact on Martian flora. And again, I like to give you a little outline. So the outline is introduction, which is more like, oops, we don't have much to say because there's very little research done on Mauritius on that. Although there are some aspects that we can discuss from what we know from elsewhere, but also there has been some work in paleoecology. It is past climate change in Mauritius. What has happened when we look in the past? So I'll be talking about that, like the past climate change in the last 38,000 years, just very quickly, and also exposed to you some of the main recorded changes in terms of temperature, rainfall, which are extremely important parameters that influence vegetation. And also then wrap up with a discussion about the existing threat. My main message to say is that the existing threat to flora today are going to exacerbate the climate change impact. That's my main message, okay? So basically, when you talk about climate change study, the two main things that we do to understand climate change. We use models, which we're not doing in Mauritius, but that's one thing we often do. We predict what's going to happen from past situations, which is relatively precise, but of course, increasing in precision as you get better and better data inside it. But the other aspect is to look at the past. You look at the past and see how has the vegetation changed when the climate was changing? Because as you see before, I told you about how the climate changed many times. So we can calibrate the time when these climate changes happened, and we can look at how the vegetation changed at the same time. So how do we do that? It's very difficult to do, but it looks impossible, but in fact it is possible. We look at pollen. for example, and palynomorphs and other things that come in tiny small things that comes from the flowers of plants, for example, they're extremely hard. They're quite easy to identify, and they produce in very large amounts. So that when they fall in lakes, go in deposit, we are able to tell. By digging a core in that deposit, we look at the pollen and we say, this plant species A was there 4,000 years ago or 12,000 years ago. You get the point. And then now the number of pollen grain gives us an idea of the abundance. So I give you a quick example. If, for example, you see a lot of grass pollen, you can say, oh, it was a dry place because grass like dry environment, like savannas. If you see, for example, a lot of tree fern spores, you say, it was moist at that time because you have a lot of ferns. So you get the point. So you can therefore use pollen and palynomorphs to reconstruct the past. So we have done a little bit of that in Mauritius. And that is useful because it allows us to understand what has happened to the native vegetation of Mauritius during the past climate change, when there was no one in Mauritius 38,000 years ago, 12,000 years ago, etc. We have a number of publications that came out of it. Some of it is not so much to do with climate change as such. This one is in the middle of the Holocene, about 4.2 thousand years ago. There was a mega drought. A mega drought, when I say mega drought, it was a very abnormal dry period that lasted almost a century. So it was very dry, and we are able to study from the remains of animals and plants in Mauritius what has happened at that time. What did the drought do? Basically, in a nutshell, the drought was unsuccessful at causing extinction of any species. Many animals died, many plants died, but none really went extinct. When humans came, however, many went extinct. So humans are much worse than a drought of 1 century in terms on motion biota. Now, I will leave that aspect, mass mortality of vertebrates, that's the idea I'm telling you. Insular vertebrates are resilient to climatic extremes, but they're vulnerable to human impact. So that's one aspect that we had. Our animals and plants were relatively resistant to climatic extremes. So, but things have changed. I will explain to you why. So the other aspect that we've done, we look at pollen in Kanaka crater, this time much further back than 4.2 thousand years ago, 38,000 years ago. By making these cores, and we calibrate by dating the different depths of the mud, we look at carbon dating, and then we look at how many pollen grains and what type of pollen grains there were at different times. We are able to reconstruct the vegetation. So, and then we can see, for example, when you have climate change, major climate change from the glacial era to the interglacial where we are now, about 12,000 years ago or something, there has been changes. But when you look at it, it looks like that. It's a bit of a strange graph to look at. But I just explained some very general thing. What you can see basically is like these are species, the pollen of some species. You see variation through time, etc. You still with me? Can you? I think there was a connection problem.
Okay.
Okay. So I lost my timer. Sorry about that. Okay. Yeah. So I was saying that we can reconstruct how vegetation changed, and in a nutshell, there has not been major changes like we've seen elsewhere in continents where the whole vegetation changed from a savanna to a woodland or a tropical rainforest. In Mauritius, there has been reassortment of species. It's very much the same species, just reassembling in different proportions. So this is what these graphs tells you. This is the abundance of pollen of different species, and you can see how they change. You know, some of them appear. Yes?
Sorry to interrupt. We can't see your screen anymore.
Okay, I'll do it. I'll share it again. Sorry again. No, it's good that you say that because it was.
Thanks.
Oops, it was sharing, but the problem of connection. Sorry about that, guys. Right, where's my screen? Yeah, now you should see it again. Right. Great. That's technology. You know, you should not be too techno optimist. You know, technology is not going to save us from climate change. Right, they can't even make us do a webinar well. Right, so so pollen grain dense identity and abundance help us reconstruct the climate, and it tells us that basically vegetation in Mauritius has been relatively resilient to past climate change. However, now let's look at what is happening now. What is happening now, the climate change that's happening now is much, much faster than natural climate change. That's the first thing, which is very important to realize. It's a much faster thing. So in the past, some species were extinct, but now with the faster pace, we will have a much more problem. And also there are many other issues as well. I'll talk about it. Other threats already exercising on, pressuring the biodiversity. So now just look at some of these graphs. Over whole of Mauritius, temperature has increased from 1960. Some of us were still alive.
We just advance on stuff. Here we got Vincent back. Let's hope we can
Okay, so now you're muted.
Okay, so share. Whew. Okay, we'll get there, guys. Can you see me?
Yes.
Am I muted? Is it?
No,
Okay.
we can hear you now, and we see also your share screen.
Okay. Okay, I use a very old map that I used for my BSc project last century. Just to try to explain something quickly, it's like, you know, when you have climate change, of course, naturally, we know very much that some places are naturally drier, other places are naturally wetter in Mauritius. So as you can see here, the bluer part are the wetter parts. In the past, when things have changed, when climate changed, if a plant was in a coastal zone and it was getting drier, the change was happening in such a way, slowly enough for that plant to be able to shift to a higher ground where it is wetter, so that it remains within what we call its climatic envelope. That is, its zone of rainfall where it can survive. All right, so you can have these shifts up and down slopes in order for species to track the environment that allow them to survive. So this happened in the past. That's why all these climate change paleoecology I showed you earlier, 30,000 years ago, we barely lost any species because the species were able to move. Now, with the fragmentation we have in Mauritius, we cannot do that anymore. Many of these species cannot move because they are locked up in small fragments. If the climate is changing around this fragment, there's nowhere to go. They cannot shift into upper grounds. Okay, so that's one important aspect that is happening because of the fragmentation of the habitat. What is in black there are fragments of habitats. So you can see they're isolated, they're not connected. So that's why we need basically to have corridors. We need to create corridors between these different fragments in order to allow natural movement and basically plants and animals to deal with climate change that's happening. They can migrate. Okay. So the other point which is interesting that we have lost a lot of vertebrates in Mauritius, a lot of species, frugivores that were disseminating seeds. And of course, dissemination of seeds is exactly what is in the way how most plants, 95% of the species in Mauritius actually move through this landscape, is by their fruit being eaten by animals and then the seed disseminated. So now without frugivores, we have already seen that habitat fragmentation is a problem, but without frugivores, that problem is even more acute, right? So the plants are going to stay put even more because no one is, or very few animals are going to move the seeds. So because we lost things like animals like dodos and tortoises, but also two species of bats, and that's my favorite subject as well. Yeah, so I have to talk about the bats. It's what is happening. The latest, the last species we have of bats has a very important role in disseminating seeds in Mauritius. You might think it's nothing to do with climate change. In reality, I just told you, dissemination is extremely important to allow species to move and to track and to remain within the climatic environment that they need. But now we're killing these bats, and these bats are therefore going to deliver that service of moving seeds much weaker level. So now on top of that, we have invasive species, a lot of invasive in very large density. In black there, they are the invasives, in gray, they're natives. So very high competition, and that is causing our native plants to disappear, basically. This is just an example where you don't have weeds. When weeds have been removed, you have recovery of individuals of native plants. When the weeds are present, you have a decline through time. You can see the years here, and the change is happening very quickly. And this is another example, this time of species richness. The number of species is disappearing as well when you have the weeds. So basically what is happening, we are losing half of the large trees. We have lost half the large trees in Mauritius protected forests in 68 years. And that makes, well, the biomass is decreasing, the species density, the species richness, etc., are all decreasing with invasion. That's invasion, increasing degree of invasion, and that's the parameter of the plant. As you can see, all the lines are going down. So it's no good. And it looks like that. This is an area which is which is restored, and this area which is dying away. This is a restored forest, closer look, and this is dying away forest. So why I'm talking about that basically is that when you're weakened, if you're a plant like here, and you're weakened already by invasive species, you will be much more susceptible to other stresses, like a little bit harsher drought that come with climate change, like some hotter days. So like, you know, a stronger cyclone. So all these things that climate change is going to bring upon us that we talked in the first presentation is going to come with a vengeance, because our plants are much weaker today, and they're more fragmented. They cannot move very much. So that's basically my main message, is that we are in a big pickle. Our plants are going to, we will really need to beef up our work to face climate change, which is going to make things much worse for our plants, which are already among the most threatened in the whole world. I mean, #2 in the world behind Madagascar, according to a recent report by BGCI. So that's it. Thank you very much. Sorry for all these interruptions.
Thank you very much, Vincent. Very interesting talk. So like I mentioned earlier on, we'll keep the question for Vincent at the end. So now we'll move on to Vikash.
Again, sorry about the interruptions. I hope we won't encounter problems, and one of the joys when technology lets us down. Let me try to put on share my screen. Okay, so if you don't mind, I'll start from the start. Is that okay with you, Nicola? Yes. All right. So
yes, of course.
I was saying that. Thank you. I was saying that we are, through the monitoring that we have of various species of plants and animals on Mauritius, we are starting to get an idea of the impact of climate change on these different species. Today, there isn't time to talk about the different species there, here shown, but I will focus on the Mauritius kestrel and a little bit on one of my pet species, which is the round island petrel. And not to say that the others are there aren't impacts, it's just that there isn't enough time to present those today. Now, when we think of climate change, you know, species conservation, to conduct the species conservation and to manage the species conservation, we need to understand the climate change vulnerability that's there. And when we talk of climate change vulnerability, it all depends on what to what extent the species is being exposed to the climate change, how sensitive it is to the climate change, and does it have the capacity to adapt to this climate change. And when you think about this framework, it is a framework that can be applied throughout any species, be it plants or animals. Now, the other thing which Vincent touched upon, and which is very important, is that climate change is not uniform, which is why it is important to look at it on a spatial scale as well, because there might be increases in rainfall in one place, but decreases in rainfall in other places, or no changes in other places. And one of the things which we found in our studies to be quite that biodiversity is sensitive to is local rainfall variation. Now, through the various studies that we've been doing, we found, for example, we've broken the year into 4 chunks, representing more or less the sorts of winter, summer, and autumn, and so on. Of course, some of you will say we don't quite have those in Mauritius. But when we break the year into these smaller chunks, what we see is that, for example, the temperature is rising in Plaisance, and this is from data obtained from the Met Office. We see increases even in Vacqua. We see increases in temperature throughout the island, and as Vincent showed just a little while ago. When we look at rainfall, it's not quite as clear cut. So you can see that rainfall is sort of slightly declining in Vacqua, and these are data that's over 50 years, 50, 60, 65 years. Look at Plaisance, it's a slight decline. But if you look at Camisard, which is an area which Vincent knows very well, you can see that there is an increase in, there seems to be an increase in rainfall for the long term. And when you look at number of rain days, you see that it appears that there's decreasing number of rain days in Vacqua region. Not quite sure what's happening in Pétrin, perhaps there's a slight decline. Seems to be more or less stable in Plaisance. But when you look at Camisole, the number of rain days is actually increasing. And this is very important for what I'm going to be discussing about right now, which is the Mauritius kestrel. Now, this study has been published, and I'm going to be quoting two studies today. The first is by Deepa Senapati many years ago, but which has now we have a more recent publication, which also talks of the impact of climate change. But she looked at the Mauritius kestrel, and she found that what actually impacts the survival and the reproductive success of Mauritius kestrel is ability to detect and to hunt its favorite prey item, which are endemic geckos of Mauritius, and ability to bring those back to the chicks so that they can feed the chicks. So just think that it's raining heavily, that the adults either do not go out to hunt, or they go out to hunt and they can't detect the prey, and they cannot feed the chicks with enough of the Phelsuma geckos. And of course, this has a chain of reaction in terms of survival of young, fitness of young, and reproductive success of young, and how they perform later as adults. Now, for those of you who aren't very familiar with the Mauritius kestrel, the kestrel was, as far as we know, present all over Mauritius prior to Brian and around the time that humans colonized Mauritius. And then it declined to the three large mountain ranges of Mauritius. In the 30s, it declined a bit further. By the 1970s, it was due to a combination of factors: habitat loss, predation, persecution, heavy use or misuse of organochlorides. It dwindles to just 4 individuals in this area here. Now, what we've done over the course of the years that followed the 1970s was to restore the population to the 3 peak the mountainous peaks. There's another recent publication that's come out that's contrasted the trajectory of the kestrel in those 4 different areas. I can refer you to that later on. But what we've done is to manage the remnant wild population. We've done some captive breeding. We've released birds. We've also been doing supplementary feeding of birds that were in the process of being released. And we attained 600 individuals at one point. Unfortunately, there's been a crash now, and we are now at around 350 individuals. Now, in the Bamboo Mountains, what happened is that we have more or less attained a stable population, and we have between 45 and 50 pairs of birds that are breeding in the Bamboo Mountains. Now, this is a species which has been constantly followed, for which there's a very complete data set of birds, breeders, and offsprings, parentage, and so on. And so there's very high level research that can be done when you have this high quality data on the bird, but also when you can actually match it with some high quality data on the climatic parameters. So let's go back to the kestrel. So a lady and a gentleman kestrel meet, they mate, they have a clutch of eggs, and the clutch of eggs will hatch, and they have a brood of chicks. The brood of chicks develop in the nest, and they fledge at one point. And in the year or years to come, they will become adults that will be recruiting back into the population. This is a typical life cycle of a Mauritius kestrel. Now, the advantage that we had on the Bamboo Mountains is that we had some very high quality data on climate, on weather data. Sorry, I take the point of Vincent. So we're talking of weather data, which we had very good quality data. Now, these were largely from rain gauges and met stations that were on sugar estates and sugar sections, as they call them. So we had 7 rain gauges that were providing monthly data on rain. There was even Camisar, which provided daily rainfall data for nearly 50 years. And this data was used to look at something which is not very is striking, which is an annual rainfall pattern for the east of Mauritius. As you can see, there are times of the year where it's very dry, and which is September, October, November, and times of the year where it's very wet, February, March, January, February, March, coinciding with the cyclonic season. And you can see quite a large amount of variation here when you look at the error bars here. In some cases, it's quite significant. So there's a typical annual rainfall cycle in Mauritius, and that applies to the East Coast as well. Now, what happens now when there's increasing rainfall and increasing number of rain days and successive rain days on the kestrel? Now, as I mentioned earlier, it affects ability to go out, ability to find geckos, and ability to bring back geckos because the geckos may not be there, the geckos may not be visible to the kestrel. Kestrel is less successful in terms of its hunting strategies, so it's less able to feed its young. Now, what we've shown is that the first year survival, so chicks that have fledged and they are in their first year survival, which is a critical time for most birds, is negatively affected by rainfall patterns during the cyclone season. In short, if the cyclone season is extremely wet and it's a very intense, a rainy cyclonic season, there are fewer birds that are going to survive their first year. Second thing that we see is that the brood size at fledging is negatively related to rainfall in December. So if the rainfall we have a wet December, the number of chicks that are going to be fledging is going to be low compared to a drier December. So if it's very wet, there are fewer chicks that are going to be fledging. What we also see is that the timing of egg laying is influenced by the pattern of rainfall in the July-September period. And especially if it's a very rainy August, the birds are going to be laying later. And in many bird families, bird orders, the early bird, the bird that is actually laying earlier has got a competitive advantage in terms of its chicks fledging. So there are advantages in laying earlier than laying later. So you can see that if we have a very rainy August, the birds are going to be laying later. And so they are disadvantaged if that is the case. And we also found that the rainfall in October is quite crucial because it determines the rate of decline of the number of eggs that are going to be laid over a breeding season. So in a clutch, you may have 2 or 3 eggs or 4 eggs, 2 or 3 or 4 eggs. I can't remember if kestrels lay 4, but anyway, a number of eggs. But if what we see is that if October is a wet October, the number of eggs that are going to be laid in the following months, the months of November and December, are going to be less. Okay. And of course, laying later is also a disadvantage to the bird. So we also found out that how a kestrel is going to perform as an adult in terms of it being able to breed, it being able to lay large clutches is affected by how badly it was affected by rain when it was growing up itself. So if it was growing up whilst it was rainy, in later years, it's going to be laying smaller clutches of eggs. So you can see how rainfall is actually affecting the whole ecology and the survival of the kestrel on the East Coast. Now, as I mentioned before, we've used daily rainfall, especially from Camisar, and we did another analysis where we split the year in June to November, which we classed the winter months, dry winter months, to December to May, which is the wet summer months, more or less. It's not clear always, finely cut. And what we found, we looked at the rainfall measures and the long-term changes. What we found out is that over this long-term data, with using this long-term data set, the rain days from June to November, which is what we theoretically called our winter, the number of rain days, especially consecutive rain days, has been increasing. And of particular note is that on the East Coast, the kestrel starts laying eggs early. So by late August, early September, the first eggs are being laid. They are earlier than on the west of Mauritius. Now, so if we have a lot of consecutive rain days in, for example, August, September, October, is actually going to be affecting the kestrels very badly. We didn't find a lot of evidence for increasing the total rainfall for that period. And in terms of rain days for what we called our summer, and you can see here December is when the chicks are going to be starting to fledge. December, January is when chicks are starting to fledge. And that is a time when you are seeing that the number of consecutive rain days, intense rainfall, is actually increasing in the long term, as you can see from this large data set. And here again, we had this weak evidence for increasing total rainfall. But what is of particular significance is not the total rainfall, it is the number of consecutive rain days. And that has more impact. So it could chuck down with rain today, and tomorrow is bright and sunny. So the bird is able to go out and find the geckos and feed its young. But if it's raining for 4 consecutive days, even if the amount of rainfall is the same over 4 consecutive days, its impact on the kestrels is actually far greater than having one day where it's showering that amount of rain. So from a kestrel's perspective, are the trends biologically important, the trends that we've seen in rainfall? And what does it mean for the kestrel? So what we saw is that there were 2 trends that came out to be significant, and that was the pre-breeding rainfall, as I mentioned here previously, and also the October rain days. Those were stats that came out fairly strong. In a more recent analysis, what we did was to look at phenological tracking, and when are the birds laying their eggs. So what we found is we quantified the effects of climate change on the breeding phenology and the success of the Mauritius kestrel. And what we saw is that birds were laying eggs at the similar rates that birds were laying eggs in tropical countries, which were also facing similar warming cycles. So they were actually, birds were advancing their dates of egg laying. And there were, however, individual differences between birds. So not all birds were behaving the same. So we do admit that there was individual plasticity. And that the bird was trying to adapt to a tiny window defined by, what is what is the weather like in the late winter, early spring, the temperatures and the onset of the summer rains, the early summer rains. So it's a small window that the birds are trying to fit in to lay their eggs. And this is a research that's been published recently. And what I've just presented to you on the Mauritius kestrel is interesting because it is giving information on a tropical birds. I mean, there are studies on northern hemisphere birds, but very little in tropical birds, and that's showing the phenotypic plasticity that you have in a tropical bird. Now I'll now move on very quickly because I know I've probably overspent my time, and on the Round Island petrel. Round Island petrel breeds on Round Island. A fantastic bird. I think we can have a whole presentation on the Round Island petrel on another occasion. But the Round Island petrel is only recorded to be breeding on Round Island, and it is a hybrid of at least 3, possibly 4 different species. So when you think about how this bird is utilizing several oceans, and several birds with different strategies are coming onto Round Island and mating,
and how these birds are facing a wide range of climatic conditions at sea. And it's actually phenomenal in terms of the variables. But one thing that we found on Round Island is that the Round Island petrel lays most of its eggs. For example, I don't know if you see my pointer here. They tend to lay most of their eggs when the sea surface temperature is the lowest. So they are tracking the low sea surface temperature, and they're choosing those times to lay the maximum number of their eggs. They will lay throughout the year, but they're choosing, there's a peak in terms of egg laying. And the reason they're doing this is because when the sea surface temperature is low, the marine productivity is high. So what the birds have chosen to do is to raise young at a time when they're able to find resources from the sea for themselves, but also to raise their young. So it's quite an interesting phenomenon, but of course, with climate change, any shifts that are going to happen due to climate change is going to actually mess up this nice, beautifully laid out strategy. And one of those upheavals in nature is, and of course, induced now more and more by men, is what we call El Nino. We had data for an El Nino, which was in 1997 El Nino. It showed very clearly that the breeding success of the Round Island petrels was depressed by the El Nino. So if we get frequent El Ninos and strong El Ninos, it's actually going to mess up the breeding of the Round Island petrels and its long-term survival. Vincent talked about cyclones, and very quickly I'll touch upon cyclones. The prediction is that cyclones are going to get more frequent and more intense in our region. We haven't seen that for the past 20 years, but we don't know what the future holds. But we do have data from two cyclones, one which was Dina, which was a very intense cyclone, and literally all of the eggs and all of the chicks were killed by Cyclone Dina. But we in a similar time period, just a year later, we had Cyclone Jerry, which was a very mild cyclone, and actually all of the birds and all the eggs survived. So basically telling you that if there's an increase in the number of cyclones, it's actually going to affect very seriously the breeding of the Round Island petrel. Now, I'll end here, but I'll just with some end notes, I'll say, the questions that we need to ask is climate change affecting Mauritius? And we are starting to get evidence to show that is affecting Mauritius and that is affecting biodiversity. There's some evidence coming from the Mauritius Kestrel, which I've presented here. And to some extent, we are gathering evidence for the pink pigeon. There's a paper that's going to come out of the impact of climate change on echoparakeet. It's submitted at the moment. There's another one coming up on the Mauritius Fody, where we've been able to show that there is climate change and that is impacting the breeding of echoes and Fodies. There is some evidence for the Round Island petrel. I presented just some small snippets of that. We also are doing the phenology of plants. I know Vincent was talking about plants, but we are also tracking plants, but it needs long-term data to be able to bring out those sorts of conclusions. But we're gathering the data. But we also see, and we also very strongly suspect that invasive species, especially invasive plants, are better able to adapt thanks to climate change. So the evidence is there, and the evidence is building up, and there's more that we need to do to actually understand what climate change, what is the impact of climate change on our biodiversity, and it just adds another layer of complexity to conservation. Thank you very much for your attention.
Thank you very much, Vikash. Very, very interesting talk. And so I see if we have a question for, maybe time for one question, and then we'll move on. So let's see if you have a question, if you can put it on the chat.
Yeah, if there are more questions, I may stay connected until later. and I'm happy to try to remain available for more questions if anything pops up later. So I can see a question. Thank you for the wonderful. Where did you get the prediction? I'm not sure what do you mean, the prediction for? No, the prediction about cyclones, that we will be experiencing more cyclones and more intense cyclones. That's from those are from the integrated, the panel on climate change. So if you look at the IPCC reports, and if you look at even the third national communication on climate change, and you look at trends, for example, from the NOAA and Australian and conclusions from the Australian Met Office, they all tend to predict that there'll be more frequent and more intense cyclones. So IPCC is where this prediction is coming from.
Okay.
Intergovernmental panel on climate change, that's what it is.
Okay, thank you very much. So if Vikash is there, we can just have more questions later. If not, we'll move to that. Thank you again, Vikash.
Pleasure. Thank you.
Hi, everybody. So good evening to everybody. I'm going to talk today about the impacts of climate change on coastal and marine resources. And just to put into the context of what we're talking about in Mauritius, we are talking about a very rich marine biodiversity. And sometimes we forget that there is a link between what Vincent said, what Vikash said, and the ocean, because when we are talking about the ridge to reef, whatever affects the land finally affects the ocean. Because when it rains, all these pollutants come down from the valley and they end up in the sea. The mangroves are in the middle of the land and the sea, and they are a very important part of our ecosystem. So our ecosystem in Mauritius, we are in the middle of what we call the Indian Ocean Indo-Pacific region. So the Indo-Pacific region is a region which extends between the Pacific Ocean. So we talk about Tahiti and the Central Pacific. We have the South Equatorial Current, which flows from the Pacific Ocean through Indonesia and then goes to Mauritius, and then it splits down after Africa. So it means that whatever species we have here, they are called Indo-Pacific species in terms of marine diversity. All these larvae are carried out from this Pacific area to the Indian Ocean, and you have a certain level of uniformity in terms of species. So you can find some fish here and the same fish in the Pacific. However, we have also, like for the terrestrial biodiversity, a level of endemicity, because we have, for example, a very specific fish in Mauritius, the Mauritian clownfish, Amphiprion chrysogaster, which is unique in the world. And we have discovered a few other fish which are unique in the world. They have evolved in a different environment. We are far away from the coastal masses. We are far away from other islands. So the fish have evolved differently depending on the system. So when we talk about Mauritius, we talk about 159 species of hard corals. We are talking about 1,656 species and 290 families of marine species, 340 species of fish, 42 being very important for commercial purposes, 160 genera of marine algae, 36 species of seaweeds have been identified in Mauritius, in Mauritian waters. And when we talk about marine biodiversity, we can say that we don't know much about the biodiversity because very few detailed studies have been carried out about the genetics of our marine biodiversity. However, the difference between the oceans and the terrestrial biodiversity is that the oceans are connected. So whatever water flows from the Pacific Ocean, goes through the South Equatorial Current, meets our island here in Mauritius, and then goes down, we have what we call the global ocean circulation. And whatever happens, and Vikash mentioned it about the ocean currents, El Nino, La Nina, regarding the temperature, whatever happens elsewhere affects our marine biodiversity. So, for example, one of the main examples that we have is that the plastics that we find along the shores of Mauritius, mostly on the east part of Mauritius, when you look at the shampoo bottles or you look at the toothpaste, you can see they come from Southeast Asia. You can see Indonesia, Malaysia, Philippines. So confirming this link between what's happening in the ocean and the fact that we are in fact in the same water mass. So terrestrial biodiversity being isolated from other terrestrial biodiversity may be an advantage compared to marine biodiversity when we talk about climate change. But one thing is sure, we are getting heat from the atmosphere, we are getting carbon dioxide from the atmosphere, and this causes a few effects on the oceans and then on the marine biodiversity. First of all, when the air temperature rises, this causes, of course, the temperature of the seawater to rise, and specifically the first 600 meters, the first layer of the ocean on the first 600 meters, we have seen that this layer is now becoming warmer and warmer. And what happens, it's a chemical process. We breathe the air when we are on land, but when we are in the sea, the organisms normally breathe dissolved oxygen. So what happens is that when the temperature rises, the quantity of gas that you can dissolve in it goes down. So whenever temperature rises, the dissolved oxygen contents of the ocean water go down, and there is a creation of what we call low or anoxic zones. So it's as if you are in an area, but you can't breathe anymore. So the marine organisms tend to live into other areas because of these anoxic zones, which are becoming wider and wider around the world. So this is the first impact in terms of temperature, that the oxygen, the dissolved oxygen, is now going down in the seawater, and it's causing anoxic zones, and it's a big stress on marine organisms. The second impact that we are having is, of course, when the temperature rises, the temperature of the ocean rises, we have the ice which is melting in Antarctica, which is entering the ocean, and we have a sea level rise. So we are talking here about 3.2, 3.5 millimeters, and it's of course changing the limit which we have between the land and the sea. So sea level is rising, so the mangrove areas are located in between, but the sea level is rising, so the land, the coastal areas are becoming narrower and narrower. And this is caused by the melting of the ice, but also by the expansion of the water masses. Around 60 to 70% is caused by the expansion of water masses, and the other by the melting of the ice. And of course, when you have more carbon dioxide in the atmosphere, it means that you have more carbon dioxide dissolved in seawater, and it creates what we call ocean acidification. We know that calcium carbonate is the baseline of marine life. You have it in plankton, you have it in corals, you have it in many, many species. And when temperature rises and you have carbon dioxide dissolved into this into the sea with carbonic acid, it dissolves, in fact, the structure of the calcium carbonate. So it means that the shell are becoming more and more fragile. The sand is becoming dissolved by this acidic water. And we are getting, in fact, this stress on the planktonic organisms, so the very small organisms, and also the bigger organisms. Also, when the temperature of the seawater rises, we have the death of the corals, because the corals have a very specific niche, a very specific range of temperature in which they can thrive. So whenever this temperature is exceeded, you get what we call coral bleaching. And this has been observed around Mauritius. You just put your head in the water and you can see corals, very whitish corals. They have lost their zooxanthelle, donc the algae which is contained in it in the polyp, and they have started to die. So we can say that in Mauritius, around 70% of our corals are already dead. And we're expecting that with rising temperatures, again, and more carbon dioxide, so ocean acidification, the corals, which are if you want, the tropical forests of the ocean, are dying. And with them, all the ecosystem which is around it, the fish, the larvae, the worms, and all the ecosystem which is around the corals are also dying. And this is a very dire situation, and it's happening around the world. And it's a very sad situation in terms of climate change. So what we can say is that all this is also going to impact coastal fisheries, because fish is used as a food safety for nearly 1 billion people around the world, including in Africa. So the fish stocks are also collapsing or moving depending on the difference in currents, in the temperature of the top level of the ocean. And this is causing a major breakdown in the marine ecosystem. And there is definitely a possibility that by 2045, all the fish stocks around the world will have collapsed. We know that 1/3 of the fish stocks has already collapsed. 1/3 is in the process of collapsing. And in 2045, you may have more plastic in the oceans than fish. And all the ecosystem is slowly dying off due to the impacts of climate change. So it's a major issue. We don't see it maybe as much as on land, but it's a global issue. It's very difficult to limit the problems linked to climate change. But of course, there are solutions. And the best solutions, of course, is to protect the environmentally sensitive areas. And a recent study has been carried out by the UNDP in the context of the mainstreaming biodiversity into the Republic of Mauritius. And there has been a recent mapping of the environmentally sensitive areas. And we can say that, for example, in Mauritius, we have now 5,000 hectares of seagrass and algal beds, 7,900 in Rodrigues, 7,289 hectares of coral reefs, 4,877 hectares in Rodrigues. We have also intertidal mudflats, 453 hectares in Mauritius and 302 hectares in Rodrigues. Coastal wetlands, 1,164 hectares in Mauritius, 234 hectares of wetlands in Mauritius, of mangroves in Mauritius, 31 in Rodrigues. And we have seen, and it is clear now, that when we talk about facing climate change, the seagrass, for example, they trap the carbon dioxide which is contained in the seawater, and they are what we call carbon sinks. So when we talk about the solutions regarding climate change, we are talking about nature-based solutions. Nature-based solutions means we have to revert back to nature instead of building walls or building structures. We have to revert back to nature to get back finally the protection we need from climate change. So the study, which is now very important in terms of protection of our marine environment, is that those maps which have been produced for the ESAs of Mauritius, environmentally sensitive areas, need to be given force of law. They need to be applied and in order to allow us to get the protection necessary against the impacts of climate change. And those maps need to be complemented by a mapping of the forest areas, the inland wetlands, and the rivers and the boreholes also inland, just to make the connection between the land and the sea. So the sea and the oceans are really witnessing a dramatic decrease in terms of biodiversity, and we are witnessing this clearly in Mauritius. And this is going, unfortunately, to go worse and worse with the years to come. So there is need to protect those environmentally sensitive areas, and also maybe carry out some exercises like what the Mauritian wildlife did with the kestrel. So we will need to try to find a way to protect the species which are slowly disappearing in the ocean, and maybe to be able to reintroduce them afterwards. So for the sea, there is a need now to build a Noah's Ark, really to protect the species for future generations. Thank you.
Thank you very much, Vincent. Very, very interesting talk, and learn lots of things today. So thank you for that. So again, like I said, we'll wait for the question at the end. I've seen you already have some questions for you, but we'll wait till the end to go to that. So thank you very much, Vincent. So now we'll move to Jan, who's going to talk to us about the impact on business.
Just quickly, Jan lost the connection and he's trying to get connected again. He shouldn't be too long.
So I don't know, Vasan, maybe if we had one question, if you want to answer the question in between.
So maybe, in fact, many people are talking about coral culture. I've seen that. It seems as if coral culture is la panacea, is the final solution to get everything on back. But what we are doing there, if we do coral culture, is just delaying the problem, because if we don't find the root cause, we'll only be selecting corals which are thermotolerant, which means corals which may tolerate some high temperature variations, but we may still destroy the diversity. So there is of course, it's a good process to go for coral culture and try to put them back in the ocean. But if we take an example on land, let's say you have a very rare endemic tree, and then you try, and then you have a lot of wild, let's say wild grass, herbe chien dent or something like that. But then you can preserve the chien dent, which will still survive, harsh conditions. But you will forget about the endemic tree because it doesn't survive those harsh conditions, and you're just starting to plant chien dent everywhere. So for the corals, it's the same thing. We have the Aquapora Formosa, the branching coral, which is growing very fast in the lagoons. Sometimes it's exposed at low tide. Of course, you can make a lot of bouturage and plant them everywhere. But is it really what we want? And when we look at the diversity at the Blue Bay Marine Park, in terms of corals, you have the foliose corals, you have other types of coral, or Lobophilia, the brain corals. So maybe we should not focus simply on coral culture and putting back the corals in the ocean, but also on the necessity to preserve diversity, and maybe not reproduce corals which are invasive and which would take the space for other more fragile species of corals. Yes, then I have the dissolution of calcium carbonates caused by ocean acidification. Of course, this is a major issue. The acidification of the ocean is breaking the structure of the plankton, of the shells, of the urchins, and of all the structure of the oceans. And this is a big issue. And it was a cause of mass marine biodiversity extinction in the past, a few million years ago, because of volcanic eruptions and an acidification of the ocean. And if the situation continues with the increase in carbon dioxide in the atmosphere, we are certainly getting there. In terms of climatic modifications, the increase in temperature will modify the activity of the bacteria in the ocean, and it will certainly change and accelerate maybe the sedimentation and the decomposition of marine organisms. Seaweed are very important in terms of food security. We said that the fish were dying and that there was a problem regarding food security, but also as what we call blue carbon. We have in the Mascarene Plateau, which extends from the north of Mauritius nearly to Seychelles. And this Mascarene Plateau is home to the world's largest seagrass community in the world. And in fact, it's the largest, one of the largest blue carbon storage. So of course, forests do capture carbon to produce wood and leaves for photosynthesis, but the carbon dioxide trapped by those seagrass beds is enormous, and there are studies currently being carried out about that, and they say that it's very, very high. So it's very important regarding the seagrass. And of course, when we take this imbalance because of climate change, rising sea temperatures, and we introduce pollutants in the water, we have an increase in blue algae and red algae, which can be very toxic to the marine environment when they flourish. And this can also be caused by climate change.
Okay, thank you very much, Vasan. So we got Jan back, so we'll move to Jan and then we'll come back to questions. Thank you.
Hi, everyone. Thank you very much, and sorry about that. I got kicked off by my laptop. Everybody hears me? Nicolas, can you hear me?
Yeah, we can hear you. Thank you.
So I'll try to bring up my presentation, sharing a screen right now. Where's that? Sorry. Give me 2 seconds, technology and me. Where's my PowerPoint? There you go. Right. Can everybody see my
We can see it, yeah.
PowerPoint? Right. So basically, I'll try to make this as user-friendly as possible and also mostly relevant. I present myself very quickly. I'm Jan Hukumsing. I work for HSBC, which is an international bank, where I am the corporate sustainability manager. It gives me great pleasure to be in such esteemed company this evening. Thanks very much to Ebony, Forest, Nicolas, and Christine and Christelle for giving me this opportunity. A big hi, et joyeux anniversaire to Vikash. Hi also to Vasan and to Vincent, the 3 V's of ecology in Mauritius, I would say, if I may. If I can start off, I would like to talk first about the IPCC report that many of you must have gone through, but I would just like to highlight what it means. IPCC, for those who don't know, means Intergovernmental Panel on Climate Change. They are the official source of science on climate change. They don't produce scientific reports as such. They collate the scientific information out there and they summarize it. I don't know if you still see my screen. Something weird happened.
No, we can still see your screen.
All right then. Good. So basically, what the report says, the report is the IPCC released a report in August, early August. It's the first in a series of reports, and that series of reports is called AR6, okay? Assessment Report 6. Prior to that, the previous one dated back to 2013, something like that. So 2013 is way old in terms of science for climate change. And so what IPCC report says, just before the COP26 conference coming up later this month, we are in a very, very, very dire situation. I just give you this information. Global mean sea level rise above the likely range, which means it's not amongst the probable scenarios, okay, cannot be ruled out because the melting of the ice caps and the glaciers and all that, the amount of complexity means that they can't really factor in and they can't rule out that we're going to be experiencing sea level rise by 2 meters by the end of the century. But more generally speaking, this is what I would like us to really have a good look at. This is what the IPCC says is the likelihood of sea level rise compared to 1900 until the end of the century. What the IPCC report says also is that sea level rise is accelerating. Compared to 1971, between 1900 and 1971, the next 25 years, sea level rose 1.5 times quicker. And since 2006 to 2014, it has doubled this annual speed. And the global average is 3.3 millimeter rise per year. Mauritius, 5.6. We all are experiencing it. We go to the beach, every one of us, we can see the filao trees, the roots are out there. And if you look here at the graph that I'm showing you, what it says is that the middle scenario, the one in yellow, they're saying that it's kind of certain that we're looking at least 50 centimeter to 60 centimeter rise by the end of century. For us in Mauritius, that means a lot. If I move to other elements I want to point out to you, is that that report has made it clear. Vincent had explained to you how climate change is something that is natural, that has occurred over millennia. It's part of the cycle of how the planet works, right? But this climate change we're going through is because of us humans, all right? And it's being seen in every region and across the whole climate system. So it's undeniable now. We are in the thick of human-caused climate change. And we only have 8 years ahead of us to try to curb the amount of greenhouse gases that we are putting out there in the atmosphere if we want to keep global warming to not more than 1.5 degrees. As you must know, all of you, we are already at 1.1 global average, right? Compared to the start of the industrial age. So that's the 1880s, 1890s, right? So we're already at 1.1. If we do not want to go beyond 1.5, there's a certain amount of greenhouse gas that we can still pump in the atmosphere. There's a carbon budget. That carbon budget is not more than 400 gigatons of CO2 from 2020 onwards. At that rate, if you look at the annual amount we put every year, like in 2019, that means we have 8 years. We need to drastically cut that. And what the science says is that that concentration has never been as high as 2 million years ago. The last time it was that high for the planet, that was 2 million years ago. The last time that temperature was at the equivalent of 2.5 degrees beyond the average of in the industrial times, that was 3 million years ago. I want us to understand that in Mauritius, we haven't really woken up, and many places in the world, but particularly here in Mauritius, haven't really woken up what's happening. If we look at temperature rises, we're looking at the last times that what we are actually going through right now, and we can see it every year now. We're having flash floods, we're having torrential rains. We didn't have that in the 1990s, right? We're looking at temperature rises that last time we had that was 6,500 years ago, and before that 125,000 years ago. So we are living in a historical situation, and a bad one. Now, the very bad news is whatever we do, even if we curb greenhouse gas emission, even if we achieve what we call net zero, that means the amount that greenhouse gas that we put out in the atmosphere, we absorb it, right? Carbon sinks, as Vincent was talking about. Even if we manage that, the amount of greenhouse gas that we've put out there and the fact that we've increased the temperature, that is going to stay. The inertia, the consequence means that the sea is going to rise. That's it, it's done. Over the next decades and centuries, the sea is going to rise. It's too late. Glaciers and polar caps are going to melt. It's done. So that is why the notion of adaptation for us here in Mauritius is crucial. The false debate in Mauritius is, we're not responsible, pas nous qui ne fait ça, les autres qui ne fait ça, nous pas responsables. Yeah, guy, that's not the problem. The problem is, it's as if somebody's house is on fire, and the only focus of that person is to say, I didn't light the fire. You should be putting out the fire in your house and then look for the culprit afterwards. The issue here is that we have to really wake up big time. And I'm going to get to it how global business is trying to wake up to it. But here are some factors that I want you to, if I can pass on to you, is that, for instance, extreme sea level in the red part, the extreme sea level events. That's the IPCC, huh? It's not me or whatever. That's the science. Events like massive storm surges and the like, that used to happen once per century. The big storms that we're seeing hitting Northern America, the Philippines, and that kind of stuff, we've been spared in Mauritius so far. These events that occurred once per century are now expected to happen at least once per year, in more than half of the locations where there are tide gauges across the world. By the way, they don't have super precise data for Mauritius because apparently the tide gauges for Mauritius are not very operational since the past 5 or 6 years, according to the IPCC. All right. So we are facing rising sea level, continued ice loss. For instance, it's pretty sure that the at least once before 2050, there's going to be a moment where the Arctic is going to be completely sea ice free, the Arctic, right? At least that's for sure, it's given. And moving on, the good news is that scientists now are more certain about what we can do that can really work, okay? So the overall notion is that we need to achieve net zero. That means the amount of greenhouse gas we put out there, we need at least to absorb so that it nets us off. And we need to remove as much as we can from the past emissions. And it has to be science-based. So sustainability cannot be anymore like, yes, you know, I collect plastic, or I've put solar PV panels on my roof, or I'm driving electric cars. What's the actual impact? What's the actual impact? You bought 3 electric cars. Was it 300 you need to buy? Was it 3,000? What's the impact? The impact, it's science that has to tell you what's the impact. And therefore, there's something very interesting emerging in the business world, which is called the Science-Based Target Initiative. Sorry, my laptop is playing up. Hello. All right, there you go. Okay, look it up on the website, on its website. Sorry about that. So the idea is very simple. If we have a carbon budget, you can kind of work out per sector. I'm very sorry about that, my screen. So you can work out per sector. Let's say I'm a company involved in cement. I produce cement. Or I'm a company involved in producing textile. Or I'm a company, I'm in bus, Rosil Transport. The amount of greenhouse gas that I put out is not the same. But all the companies in my sector, we're kind of similar. We have the same kind of output of greenhouse gases, right? So per sector, you can work out, as you can see here on the screen, aviation, aluminium, apparel and footwear, chemicals, cement, financial institutions. If we have a carbon budget and we know we can't cross that budget, you can identify per sector what's the contribution of each sector to overall greenhouse gas emissions. And from that, you can work out what's the maximum amount that each sector must not cross. And therefore, a company in that sector can understand, okay, what amount of greenhouse gas do I need to reduce so that I'm no longer contributing to catastrophic climate change? Reversely, how much do I need to achieve by 2050, by 2040, by 2030, right? So for instance, the company where I work, HSBC, we have committed, like many global corporates, that our activities, like our offices, our transport, all that will be will be net zero by 2030. As much electricity that we use in the office, as much air conditioning that we use in the office, we need to make sure that all that is net zero. Then before 2050, we have to look at our client portfolio. We are a bank. So we must make sure that the businesses that we support, our clients, their greenhouse gas emissions also are net zero. Because then it's only then that HSBC can say, me as a company, I'm not contributing to catastrophic climate change. And the other banks are doing the same. And Pepsi is saying the same. And Coca-Cola is saying the same. So everybody is trying to see what is the maximum limit of greenhouse gas emission that I must not cross, and what's the difference from where I stand now, and how much I need to reduce completely, and therefore invest in new technologies, new ways of doing things and all that, so that based on science, I am not contributing to more than 1.5 degree global warming. This is what is happening in the business world right now. And no, not really happening, starting to happen. But and therefore the UN has created this, the United Nations has created this initiative called Race to Zero. We have to race. We have to run. Then I would like to bring your attention to something, to bring the conversation back to nature, something that was released in February this year, which is many people think is going to be decisive. It's the Economics of Biodiversity, the Das Gupta Review. Basically, climate change is the reminder that the way humans have been living is unsustainable considering nature, considering the climate. And because we have always behaved ourselves as if, yeah, there's no limit, there's no constraints, we can consume how much we want, we can deforest how much as we want, there's the nature that we don't look at what's the impact on nature. And that's the lesson from climate change. That's also the lesson from COVID, right? So this report called the Das Gupta Review brings nature back into the mainstream of economic thinking. Das Gupta is a professor at the University of Cambridge. He was commissioned by the UK government, which is hosting the COP26 conference. And the report that he has put out says many things that for many of us are obvious, but it's the official confirmation that governments, like institutions now, it's no longer the hippies and the Greenpeace and the tree huggers saying it. It's the mainstream decision makers who need to accept it. And if it goes as the trajectory it's going, it could be as decisive as the Stern review. So we're talking here about the Das Gupta review. There was in 2006 a review on climate change called the Stern Review, Professor Nicholas Stern. And back then, it was as much groundbreaking as this Das Gupta review. And today we're talking climate change, we're talking about net zero. This was launched in 2006. So the Das Gupta review, hopefully in 15 years' time, we will be in a position where we'll be talking about how nature is fundamental to economy. So it says that we should be accounting basically the obvious. Society and economy doesn't exist without nature. We are part of nature. We can no longer behave as if nature doesn't count when we're doing our balance sheet and our accounts and our HR payroll and our profit and loss balance sheet. Everything is provided for by nature. All the raw materials that we use, the energy, the food, the air, it's ecosystems, it's the air, it's everything. It's nature-based, right? So I just wanted to bring that to your attention and conclude on that. So it's forcing a full rethink of how the economy is supposed to work. Nature is our most precious asset, and as we all now are really, most of us are aware, is that we have been living beyond our means. We have been living as if we have 1.6 Earths. So that talk was a bit on the margins. With that report, it's becoming into the mainstream of decision makers in government and in business, the banks, and all that. So I would suggest if you can have a little look at the Das Gupta review, because for me, there's going to be a big focus in the coming years on reforestation, for instance, because when a company will have reduced the number of the amount of greenhouse gas that they emit, they've switched all their cars to electric cars, or the lighting to LED lighting and all that. There's always going to be a minimum amount of greenhouse gas that's going to be emitted, and that needs to be offset. That's where you need your carbon sink, your seabeds, your seagrass beds, sorry, in the lagoon, your forest at Ebony Forest. And there's going to be a real demand for business to fund that, because, for instance, HSBC, we will never able to get to net zero only by reducing our fossil fuel use and all that. We will have a residual amount of greenhouse gas remaining, and therefore we will have to invest in ventures such as Ebony Forest and all that. The trick there will be greenwashing, how to make sure that it's genuine. So we'll leave that for another debate, but it's coming. Massive investment in nature is going to be happening more and more in the coming years. So there's a silver lining to all the bad news, is that nature is going to get the resources that it so badly needs. Will it be too late? That is going to be the big question. Thank you.
Thank you very much, Jan. Very interesting too. So we had all our presenters. So now we can start with the questions. So I'll go back up and then we see which can apply to the questions. So So I think some have already been replied to. And Vasan said he had to leave, unfortunately. So I don't know if someone else among us can answer question. So Jan, there's a question from Claudia who said, data for Mauritius is scarce. Is it because it does not exist, or is it locked somewhere? Should data like temperature, rainfall, layers for mapping, etc., become freely available to increase knowledge on climate change impact?
I think the answer is in the question already. Obviously, the more data we have and the better decisions we can make and take. So we need, obviously, one, we need to generate scientific data. So there's an issue there regarding Mauritius about, do we really have all the equipment out there to produce the data that we need? Apparently, according to the IPCC, there's issues about the tide gauges that we have in Mauritius and all that. And obviously, once you generate the data, is it freely available? Developing countries, modern countries, they progress because the data is available to everybody. And therefore, more people work on the data, the better the solutions and the better ideas come together. Unfortunately, in Mauritius, we don't have as yet that culture of open access to information. And I think that's a challenge that we will have to address sooner rather than later.
Okay, thank you very much. My first question, thank you very interesting. What about the SDGs, please? And I think maybe that's what question was for you, Jan. But of course, if anyone else want to answer.
Well, so the Sustainable Development Goals remain relevant. We were talking here about climate change, the fight against poverty, gender equality, the fight against hunger remain relevant. That's obvious. That's for sure. It's not either or. It's part of the. It's called. There's a jargon term in the business world, ESG, environment, social, governance. They call that. Yes, SDGs will fall into that. So I would say climate is a subset of sustainability, a subset of SDGs. But the topic today was climate.
Okay, and then we have another question again. I think that's Vincent, go on.
Just one thing which is interesting about the SDGs. A recent report from the UN, the SDG 2021 report, showed in Mauritius, for example, of the 17 SDGs, there's only one that's trending downwards, and that's terrestrial biodiversity. That's an interesting thing. And more now we're starting to see that people are not, they're starting to think that SDGs are not ambitious enough, but they are good goals, but they are slow. They are slow, and they're not going to meet. Seem not going to meet a lot of the challenges, even in the best scenarios. So there's a debate about maybe SDGs are too low goals, and they are too centered over development, and development has to really change fundamentally the concept of development. I mean, just a quick little personal thing. I mean, we talk about sustainable development as a new thing, but development should have always been sustainable. That's the thing. So it's like we just discovered something new, which is something that we've been doing wrong all this time. So anyway, and the SDGs are very development biased, and I would invite people, I mean, if you can, you'll read the paper by Chris in I think Science in 2018. It's a perspective piece. It's a really nice eye opener. How humans are basically centering everything around that one species. It's like everything is there to serve us, and it is that worldview that is sinking us collectively. So we need to be a bit more humble about how we view the world.
Okay, thank you very much, Vincent. And then Jan, you have another question for you. What about carbon evasion? Many companies are known to export their carbon emission to developing countries. You can be carbon zero in Mauritius, yet in some other countries, same company is loading the atmosphere with carbon. So does the corporate initiative take this aspect into consideration? Is it at a local level or global level?
I think that's a very, very good question. It talks about the difficulty of making really meaningful work here. Basically, I would take that question on the generic label of greenwashing. So there's, for instance, a business about carbon credits, and it's very volatile, and there's no real norms, and it's a bit like the Far West for the time being. There's no real control. So, for instance, as that person is saying, India, is that a company can, outsource their carbon emissions in other parts of the world and that kind of stuff. But if you look, therefore, at what that initiative I pointed out, SBTI and other ones, they are really trying to put together a framework where there's no leakage, where there's no duplication, where there's no some kind of a falsehood, because you stand as a big corporate. The minute, especially in the social media world, the minute that you get labeled as a greenwasher, as a hoax, you lose massively. Your competitors will just jump on that. Let's say, imagine that Coca-Cola comes with a silly claim about their product being XYZ. Pepsi will just jump on any opportunity to say that these guys are liars, and their shares will fall. Shareholders will pay for blood. Investors will pull out. That company goes down. We've seen it, for instance, Volkswagen. There's a big, massive scandal, Dieselgate scandal. They were saying that, yeah, the vehicles are very good for the environment. Actually, they were faking it. So the time for fakers is that space is thinning down. All right. So the question is, how do you get, as Imtiaz is pointing out, accurate data? So if it's a multinational company, or if it's a company dealing in Europe, but then outsourcing to, how do you capture all that? So we're not there yet. The short answer is that we're not there yet, but systems are being put in place to make sure that claims regarding the climate by a company are backed up by objective evidence. So you can't make just like marketing PR statements. So short answer, we're not there yet, but they're putting in place norms and frameworks for this, exactly that kind of loophole to be plugged.
Okay, thank you. And we have a question from Ryan. How can we make sure that the work to fight climate change will be a long-term process? I don't know who wants to answer.
I don't know. I may attempt quickly. I mean, I think people should. First thing is, as Jan and many others stress, I think we really need to first remove all the clutter and all the hoax, or conspiracy theories, the QAnon kind of stuff, and really try to just settle the false debate that is actually blocking climate action. False debate, we know very well that they're driven by lobbyists, because there's a lot of lobbyists which just want, which want business as usual. I mean, it's the same toolbox that's been used for tobacco industry some time back. It's exactly the same thing that is happening with climate change, to delay action. So we know that much better. So we should be breaking that and move towards more evidence-based, view of things, and at the moment it doesn't look very well. When you look at what's happening in the United States, for example, Republican and Democrats and stuff, and the level of disbelief in science has grown to enormous proportions. So we really need to trust the science, and we also need to really act intelligently. We are called Homo sapiens. Homo sapiens means wise men, and there's nothing less wise than to destroy the very living system that's keeping us alive. So I think we need to sober up and find a solution that's workable, not break our back, because we need to shift as well, because the systems, the economic system, the society is organized around some kind of rules which you cannot break in one go. You need to really find a transition in a smooth way, so that you don't get revolt and uprising against you when you're having a climate mitigation agenda. Because otherwise you get kicked out of office very quickly, and then you get Trumps, and more Trumps will get into office. So I think it's a very fine line. You need to really try to make people understand science is what you should look for, and tread that line of reason change, which is sufficiently ambitious but not too fast, because society would probably not follow you as well. You have a lot of unrest. I don't know, that would have been my answer, quickly said.
Thank you, Vincent. So Owen wants to have a statement. So Owen, if you want to go on with your statement or your question.
I just wanted to say that there's globally a lot of focus on climate change, which is what this is all about. It's critical, and people tend to forget, although it's been mentioned here today a lot, but globally people tend to forget just the incredible loss of biodiversity and the link with that. And I just wanted to first of all make a statement about that. I was speaking to a friend today about a large block, or the only big block, of dry deciduous forest in Western Madagascar, and he said a third of that has been lost in 2021 alone. This is a major challenge for the world, the loss of tropical forest. It's going fast, and focus needs to be placed on that too. How to resolve that, I'm not sure I have all the ideas, but people shouldn't lose sight of the critical importance of that.
Thank you very much, Owen. Okay, and we have a question. Does climate change affect a person's salary? I don't know who wants to answer that one.
Yes, it will. And there are many ways, positive, negative. Yeah, it will. It depends, because the climate change, yes, I mean, there's a lot of opportunities in renewable energies, for example, and then you can suddenly, or if you are in renewable energies, you are being neglected, and now, you know, things are going your way, your salary might go up. So yes, and conversely, I mean, in a very gros trait, if you are in extraction of fossil fuels, your salary might go the other way eventually. So, I mean, just two very big extreme and very coarsely said, yes, I think it does, but it ramifies in many, many ways too.
Okay, and we have a question from Facebook. A few companies have been doing carbon trading to be net zero. However, they trade their carbon overseas when their impact are felt here. What are your opinions?
What is Jan's opinion?
Yeah, no, it's not my opinion. I mean, it's the facts that count. Is that we really need to get this kind of mess sorted out. I mean, obviously, it's the reality of climate change is going to be hitting us very hard. So there's no two ways about it. People are going to be losing their livelihoods. Companies are going to go bust. Countries are going to be really affected. So that at one stage or another, you will see governments are going to start taking regulations. I mean, already COVID has had that kind of impact on governments saying we're no longer going to be authorizing this and that and the other because they need the money now to stay in the economy to sustain themselves, right? So the more there's going to be impacts and on countries, governments are going to take action, and companies who try to do rogue actions will be called to correct that. But the question is how fast, how quick enough. So what I see is that there's COP26, that conference coming up, will be very revealing about how effective global business and global governments and all that will take or not, and be at the rendezvous de l'histoire. Because clearly you will have people trying to do dodgy deals and okay, I'm protecting the planet in my country, but actually I'm destroying rainforests in Indonesia. So, but the information now is available, the science now is available. It's a question of putting together the regulations and the frameworks to make sure that that kind of behavior cannot go on and is prohibited, and there's penalties and fees and prison sentences, hopefully also. So we don't have the answers yet to that, but that's clearly the sort of challenges that need to be addressed.
Thank you. And Vincent, a question from Claudia. Jan says that reforestation will increase. Our reforestation should be done in Mauritius to also support our declining biodiversity.
Yeah, I don't understand why she didn't ask that to me directly, but anyway, no, I'm kidding. She's in the other house, actually. She's not here, right? Yeah, okay. Restoration is very interesting. It's something which is growing worldwide. It's because of the many benefits that it brings. It seems to bring, not just for biodiversity, for water, for ecosystem services, for a lot of stuff. So in Mauritius, I mean, we are one of the most deforested places on the earth, most rapidly deforested as well. So you might think that there would be quite some, prospect of reforesting areas which are completely gone. There's no forest at all, like abandoned sugarcane plantations and things like that. That could be something to be done, I think. And indeed, the Protected Area Network project, the concept was to basically also connect the fragments that we have around in Mauritius with this reforestation. However, I think much more urgently would be the restoration of forests which is already with native content. As I said earlier, we have one of the smallest leftovers or remaining habitats of native forest in the whole world. And we have, in many decades of active conservation work, we have literally we are restoring just 1/20th or even less than 1/20th, like less than 5% of those forests that we have. So at this point in time, we really need to upscale restoration. That's a good question. I see it in that sense. Restoration is going to help climate change mitigation. It will allow us to, sequester carbon. It's good for us here as well, because these forests will provide a lot of ecosystem services for the marine environment, fighting against erosion, fighting against fertility loss in the soil, and many other things. But I think our restoration in Mauritius, we're doing great stuff, but we really need to upscale it. We really need to do at a much grander scale. And in many years, in many decades, we've been having sometimes millions of dollars pouring into restoration, and we've done that small amount. So we really need, I think, to work with nature and to do faster and bigger. And there are relatively easy way of doing that. The weeding, we know, is very, very important. I know we do a lot of active, a bit micromanagement that can cost a lot. When you have money and when you're dealing with small areas, it's fine. But if you want to restore the forest at the level that is required here, we really need to work with nature. And my recommendation is to weed the maximum and propagate and plant a very limited number of species, or those which cannot do it by themselves, but otherwise let the forest regenerate by itself. It does it very well. We've seen our research, forests regenerate extremely well. For the 90% of the species regenerate very well. We don't need to do it. If you plant 1 tree per meter square, for example, nature plants 5.5 at no cost. While you're sleeping, it is still planting it. So, I mean, we need to think this way, think natural. Like I think Bassem said earlier, nature-based solution. So we really need to restore big, and it is not that impossible. It's not a question of upscaling the amount of money that we're spending on per hectare. It's about also changing the approach that we use to restore forest, with less interventional and more, weeding, and then little bit of planting and other things. I mean, rat predation is a major problem. If you get rat control and monkey control and remove the weeds, that would be the priority, I would say.
Okay. Thank you, Vincent. So we got a question from Ebony. Jan, like you said, many companies will be going for net zero client in the future. How are they going to assess this? Are net zero materials product accessible to the population? Many eco-friendly items are more expensive. What are the ideas to transition to the eco-friendly net zero product by including everyone?
That's a very, 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 very relevant set of remarks there. For instance, it implies that the notion of a just and fair transition, that you don't leave people behind, and that it's fair to everybody, because obviously, if we phase out, for instance, so if we move to net zero, that means some certain economic activities will need to be phased out completely. Let's look at coal, for instance. Coal needs to be phased out, fossil fuels needs to be phased out. What happens to all the workers and the countries who depend on them, and the families who depend on them? So it's the question here is about a complete shift of how the economic system works. Hence, I pointed out to you guys the reading of the Dasgupta review. Short answer to this is that on the shift, the economic shift is happening. It's already happening. Is it happening fast enough? That's the question. Some products that were, it's still costly if you want to go to products that do not harm, do not contribute to harmful climate change. It's still more costly. But things that were not accessible before have become accessible today. For instance, we've seen the shift from plastic takeaways and all that kind of stuff to paper-based ones, right? So this is something that only 10 years ago would have thought unimaginable, because of the economies of scale that would imply using polystyrene rather than plastic compared to, but it's coming. Obviously, it's let's see, if I look at electric cars, it's something that is not available to everybody. It's costlier, but it's going to democratize and get available to the masses. At the same time, it's not the solution. The solution is not electric cars. It's electric buses. It's electrified public transport. It's no point of having more and more electric vehicles, right? So we are in the middle of a transition. We're in the middle of the transition. Good question by Ovani. Who will be the losers? Will everybody win? Will Mauritius be as affluent, we can say, because we're kind of a middle income country. We're quite, by our standards, we're living much better than our parents. Will that be the case in 15 years' time? We don't know. It's our destiny is happening right now. In the next 3-4 years, it's happening right now. The more people are awake to that and paying attention and taking action, the better the chances that we come out of it successfully.
Okay, thank you. And we have a question from Facebook regarding effects of climate change on our flora. I have been germinating native plants for a while. Usually germination was better during summer. However, I am now observing more germination during October and November when it's drier. Have you observed similar effects in nature? So I guess that's for you, Vincent.
Yeah, I mean, well, we have not. A short answer, we have not observed such effect because we are not studying such effects. At the moment, most of our studies in our team has been directed towards the influence of invasive alien species on the flora regeneration. And there's an enormous amount there, and it's very, very heavy. So indeed, this kind of thing that is being described about germination timing is can be expected. I mean, it demands quite a lot of study, of physiological study and experiments to actually establish it in a very robust manner, in a scientific manner. But it would not be surprising if that is the case, because we know that various cues are going to triggering germination of species, but then not all species react to the same way to these cues. So each one has its own set of cues that they use to germinate. So it is possible, and elsewhere we know that plants change their germination rate or germination timing, etc. with climate change. So it is possible. At the moment, though, it remains a relative minor thing compared to the huge impact that is being delivered by invasive species, which is really swamping the rest. So basically, I think we need to save our biodiversity from invasive species so that we can later on save them from climate change, because they might disappear before they get hit full swing by climate change.
Okay, and another question again from Facebook. There has also been insect infestation during summer on my native plants. The timing of infestation is getting longer. Is there any studies on this? So I guess that's also for you, Vincent.
Yeah, I mean, I'm not aware. I mean, yeah, the thing is, infestation on native plants like mealybugs and things like that are very common, especially when they're cultivated in garden setting, because garden setting are very impoverished in terms of predators, and the ecological function of predator of pest control, etc., is very much dampened, very much reduced in a garden setting because of its definition itself. It has low diversity, so you may expect much bigger ups and downs, more amplitude, greater infestation rates, etc., because there's very few predators to take them off. So that's one thing. But whether or not this is influenced by climate change is, yeah, it is very well possible. We have insects opening up and proliferating in new temperature settings. But again, it has to be looked at in more detail. I mean, we know, for example, mosquitoes are changing their geographical range, and now we are having mosquito-borne diseases in places that they didn't exist before due to climate change, for example. So there are these kind of things that do exist, but again, I would say it is important, before we conclude to climate change, it's important to have a robust study, because there are potential other explanations as well. It could be pesticide use that's killing the predators, for example. It can be a declining, the microbat species declining. Therefore, the predator of their pest is not the pest species are increasing in numbers because they're no more eaten by insectivorous bats. It can be a lot of things, and also a lot of things together. So it is possible, but it has to be studied.
Thank you. And then another question. Maybe the problem is the way data is delivered to the general public. Us as scientists, we do understand that the prediction of 2 meters sea level rise by 2100 is catastrophic, or an increase of ocean temperature by 1 degree is deadly to corals, for example. But how do we convince people of the impending danger and motivate them to help fight against climate change? I don't know who wants to answer that one.
I answer that, of course. Okay. I guess it's a bit like the question earlier, how we actually pass into people. I mean, the problem, I mean, a personal problem I see, unfortunately, is like more and more nowadays, because, things like Facebook, social media, it allows a lot of people, it democratizes what people can write. A long time ago, writing was mostly by, more trained people. Nowadays, anyone can write, which is in some ways a good thing when you can voice your opinion, but it can become a toxic thing. Some people have described, for example, social media and stuff like that as a vast bin in some cases. So, and to some extent, it's a bit true. Anyone can say anything because there's no peer reviewing, there's no verification. So then you get a lot of information, which a lot of it is basically garbage. And then people believe these things. I mean, look at what's happening with COVID-19. People are killing themselves because they believe in Facebook. They make a research by sitting on the toilet and looking at Facebook pages or internet. They call it research when, it is not fair at all. So we have great access to knowledge nowadays, like never before, but we seem to be going towards the most sensationalist, and, we are very easy to be steered away and manipulated by people who have an interest to do that. So I don't know, eventually, it has to be led by the drivers of the economy, the business, politicians, even religions must come on board, etc., so that we federate everybody, because we don't have time. Like Jan said, we're really running out of time, and we really need to show to people that this is happening. So we stop the noise, stop the nonsense about climate change being hoax, etc., and focus on solutions. And the business can create these solutions, renewables, etc., so that people just move into that direction because it's profitable to do so.
Okay, merci. Another question, maybe that's for Jan. How would a circular economy really help?
Well, I think it's part of the solution, definitely. You avoid waste, you make sure that you are no longer these linear modes of, you're extracting from nature, transforming, consuming, and then throwing it away, and then you extract again from nature. So you try to keep things, we use them, reduce the impact on nature. So that's definitely part of the solution. But this would go, for instance, towards what Owen has been saying about the loss, drastic, tragic loss of forest taking place, instead of cutting down wood. So basically, but if we're talking about climate change, so basically, this is a good question, because it shows that climate change is a subset of a wider issue about how we're sustaining ourselves as a species in the overall planetary system. So we're getting rewarded by climate change because of our bad behaviors, and there's so other bad impacts also looming around the corner. And hence, again, as I was saying, what the Das Gupta review has pointed out is really where we need to go now, really big time. So obviously, circular economy is something that will have to take root and buy local instead of eating some fancy fruits that's been shipped like from the other side of the world, instead of eating local fruits from the garden that we used to have previously, you know, the fruit trees in Mauritius that we used to have in family gardens, instead of buying some fancy imported fruit in the supermarket. So that's definitely one aspect that is contributing to climate change. And all that. So yeah, it's part of the solution.
Thank you. Another question from Facebook. I have been restoring habitat, as Vincent said, which borders mountain reserves and have a few native remnants. However, since this is a small scale project, 7,500 square meters, by a private individual, is it possible to sell my carbon deduction locally, and how do I do it? So I don't know if you want to answer, Jan. If not, I can add a bit also.
No, I think it's a valid point. I mean, the thing is, I'm saying is that we don't have the mechanisms, the market mechanisms are not really there yet. There's people there who might be interested, people who aggregate, who will go and walk around and see, okay, who's got a bit of a plot of land. I'm sure they would want to get some carbon credit, but they don't know how to go about it. They don't have the time for it. So I will sell that service to them. And I say, okay, I can package you and you and you and you and you, and have this overall carbon credit program, and I'll take 10% off it, and I'll take 20% off it, and this is how it's going to happen. Like, people are going to become intermediaries in terms of sourcing funding from the carbon offset markets. But for the time being, it's a bit of the Far West. You get all sorts of carbon credit specialists out there. You get it's pretty much disorganized. And is it viable? Because they can come and tell you, look, you pay me first, and when the money comes for the carbon credit, I give to you, and actually you'll win. So there's also, it's not clear cut. It's starting to get better organized in the bigger countries like Australia, like USA, and that kind of stuff. So we're getting there. But at this moment in time in Mauritius, unfortunately, it's not there yet.
Thank you. And if I can add to that, I think that's also a big problem. What we are seeing in other countries is having a numerous number of middlemen that take a percentage of the money. So that's the problem. So people are paying, and it's a really, really small amount that go back to the people really doing the reforestation or doing the carbon reduction and stockage. So that's also, I think, something that need to be looked for it to be really worth it in the future, because loads of money is turned as a business. So people are just using the system to just get richer, but the money is not, or a very, very, very small amount. Because I think I read something about but if $50 are paid to reduce carbon emission, only $1 gets to the person that are doing actually the reforestation or any form of carbon reduction. So that's also something I think is going to be a big problem. Okay. So I think we don't have any more questions from what I can see. So I would like to thank everybody. We went a bit out of time, but I think it was no point stopping, because I think we had really interesting question, interesting debate, which is great, I think, for concerning climate change. So again, I would like to thank all the presenters for taking the time at night until late. I'm sure everybody's a bit hungry now, but that's good. And I think it was really interesting. And also all the people that followed the webinar. Like we said, there's going to be a next webinar, which will be on mitigating impacts of climate change. So we'll let you know, we'll post it on our Facebook. And of course, you can follow what we are doing at Ebony for us on our social media. You can show our support and of course, spread the words. And like usual, we are going to advertise because like you know, we do lots of free courses, webinar, workshops, so we'll advertise that. And now that you've been contacting us. Usually we get your emails and we're going to send you some news so that you know what we're doing at Ebony Forest. So I think, thank you very much. I don't know if Jan, Vincent, or Vikash have a last word to say before we just close the webinar.
I'll just say thank you. I mean, it's been great. Thanks a lot, Ebony Forest, for organizing that kind of event, because I think it's brilliant to have like 50 people at that time still around, getting this opportunity. Also, I get great questions, challenging questions. Please keep on that good work, Ebony Forest. I mean, you're not only doing great work for the forest, but also for the minds of the people. Thank you.
Thank you. Vincent?
Yeah, but that's it. It's a cut and paste of what Jan just said. Yeah.
Okay, right.
Thank you very much to organizers. Thank you for everybody attending. Thank you for the speakers for sharing your knowledge. I really learned a lot today. I'm really happy, and I'm looking forward for similar webinar again, and encourage you to continue. It is really you really find something very interesting to do here.
Thank you very much.
It's coming regular as well. Thanks a lot.
Okay, well, good night, everybody, and hopefully see you for the next webinar. Okay, thank you again, everyone. Bye.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.
Bye.